Cool. Thank you everyone for coming. So my name is Sang-won Lee from Computer Science Department. As you all might have known, I'm one of the MISC coordinator, and I'm abusing one of the talk series as part of my job talk practice. So hopefully you'll be fine. And I'm collecting a lot of feedback and questions, so if you can open up the document and leave any comments that you have, or leave a question, like potential question that I may get during the job talk, that would be great help. For your information, I'm going to be, the audience will be computer science audience, so it could be technical question. So yeah, at least I'm glad that we can all have one more round of free food. Okay, so let me actually start. So yeah, I'm very glad to have a chance to talk about my research work that I've done in past years on live collaborative creation. So one of the most important goals for human-computer interaction researcher and practitioner is to better understand users. It is because our goal is to create an artifact that people need. And eventually we want to provide an engaging user experience with the artifact. However, the challenge here is that creators need to know how it is going to accomplish the goal in advance when they design and create an artifact. So, and this is a common problem, regardless of what you create. And there is a very clear separation in multiple dimensions between the creation process and the actual usage. For example, the food that you order in a restaurant is typically cooked in the kitchen and served to a table, so there's a distinction between in terms of the space. Or the software that we write every day as a programmer could be written in a dark room that has no window, but it can be used in a completely different context. So the problem that I'm trying to highlight here is that creators are disconnected with users. They cannot have immediate feedback. Therefore, reflecting users' feedback to improve the artifact either takes too much time or it's not going to happen at all. So, in the field of human-computer interaction, researchers have addressed this problem via various methods of user involvement in the design process. For example, we often conduct a usability test in the lab and study how people use an artifact, or invite stakeholders to be part of the design process sometimes. Or even researchers visit the context that users are in and try to understand the problem they face. However, it is still going to take a long time to collect feedback and improve the artifact. Furthermore, the involvement itself is not the most pleasant experience for the participants who are involved in the process. It may even be intimidating, which contradicts our goal of providing engaging user experience. For these reasons, it would be great if it can minimize the delay between user involvement and its effects. And also, people who are involved in the creation process should also have an engaging user experience. So the goal of my research is to make the user involvement more engaging and more immediate. And I wanted to find a solution from my own personal experiences. And I remember this particular painting, which is decent, but not amazing, I would say. The reason why this was memorable was because this was part of the TV show that some of you may recognize. Typically, a painter may not want to draw in front of people, but this painter named Bob Ross was bold enough to do it in front of people. I'm not sure if you can hear the sound. So I personally recall that, let me actually see if I can, I guess my laptop is big enough. So I personally recall this, like watching this process was mesmerizing to witness how it evolves and how effortless it looks and how it motivated me to think that maybe I can do it too. And I'm almost tempted to say that the process of creation is more compelling than the artifact itself. Another example is food. Let's suppose this is the food that you order in a very high-end restaurant. You may not be most pleasant because it doesn't look too different from what you could have done at home. But however, people love this kind of food probably because it was cooked in front of them and they see how it is made and see all the ingredients goes in it, and it is immediately served from the grill to the plate. And people value this live performative aspect of cooking process as much as the resulting artifact. There, I find the potential of creating artifacts live in front of people, as if musicians perform live music, or an instructor live code in front of students in a classroom. In this case, users get to see how an artifact is created in real time, and the delay between the creation process and usage can be minimized. From the user standpoint, being there in the creation process provides a lot of contextual information about the artifact that can be effective for having better user experience. More importantly, live creations opens up an exciting opportunity of user involvement by offering them to participate in the creation. During my doctoral study, I have developed interactive systems that guide end users to be involved in the creative process and mediate collaboration between creators and users in the various applications. In this scenario, users make actual contribution and give immediate feedback to the creators and eventually build a sense of ownership on the artifact that they create. So before I go into detail, for the purpose of this talk, I would like to give you a definition of both live and liveness. So when something is live, it means that the process of creating an artifact is visible in real time to people who are involved in the process. For liveness, it is the extent to which the process is immediately and continuously visible to spectators. And many existing works have hinted that liveness facilitates engagement. It dates back to the research in collaborative design, where researchers found that being part of the creation process provides richer information than, to the participant than the resulting artifact. And recently, with the growing interest of MOOC and live streaming, such as Facebook Live, we have started to see the notion of liveness in digital media and computational system and its effect in facilitating user engagement. Therefore, what I've done in my research is to introduce the notion of liveness in computational system. To that end, I developed interactive systems that transform what used to be non-live into something live for the purpose of user involvement. And I developed interactive systems that facilitate and preserve liveness in context of collaboration. So let me give you one extreme example of live collaborative creation. So let's suppose there are two programmers that are developing a graphical user interface for a mobile phone. What's different from the usual is that both of them are working on a single program on a remote mobile device in real time. So they are sending code text from their laptops to the device over the Wi-Fi network, instead of working on their own copies on their laptops. More interestingly, at the same time, there is a user who is using the software that is being developed. So initially, the application will have nothing because they're building the GUI from scratch. But as time goes by, the GUI will get complicated with interactivity added on the fly. So please hold on to the question why someone would ever want to do that. Except that it's a very interesting setup where the development and the usage is happening at the same time. It's almost like you're playing a piano while someone is building a piano. So in this scenario, there are various challenges coming from this live collaboration. And the first challenge here is that the program state is not clearly visible to the programmers, because the artifact that they create is on a remote device to support the user to use it at the same time. In addition, the underlying program state can change by one of these three people. Therefore, the programmers need a way to learn what kinds of changes are made on the program state. Second, the programmers need to be able to freely and rapidly write a program without worrying about potential conflict like having same variable state. Lastly, the usability of the application is dynamic because graphical user interface change arbitrarily on the fly, so it can be annoying for the users. To address these problems, I made a web-based development environment that you can see the program state of a remote device in real time. You can see the list of variables and functions or any expression that can be evaluated as well as their values at the moment. So it is something similar to a debugger, except the fact that the program is continuously running. With this tool, a programmer can get a live view of the program state through this visualization tool. So you can see the variable value changes as the user interacts with it. Also, a programmer can change the program state without worrying about any conflict, because any code evaluated on the fly will be only available in individual namespace by default. They can selectively share any variable or function by exporting it to the shared namespace if both programmers want to use a function or a variable. So this was in fact a research work done in the context of computer music, where 2 programmers and 1 musician collaborate to perform a very experimental music piece. During the piece, programmers developed a musical instrument from scratch on stage in front of the audience. And musician improvised on the live coded musical instrument. Obviously, the first few minutes of the piece was complete silence. However, the audience loved the idea of that even writing a software can be part of musical improvisation, and they appreciated our efforts to write a program on the fly as a performance. So this is somewhat an extreme example of live collaborative creation. So would it be possible to extend this new mode of interaction beyond an experimental music piece? And I believe the answer is yes. I think there is a great potential in supporting collaborative programming, especially in the context of data science. Like programming environments such as MATLAB or R have similar ways to represent the program state. However, it does not well support remote collaboration in which people can work on a shared data set. The computational tools that are developed for a programming environment can be used to facilitate remote pair programming in data science, with potentially additional users who can see and use the data set in real time. So why don't we do everything live then? Like if it's good, like we can involve users and it's engaging, why don't we do it a lot? So maybe you can ask yourself why you wouldn't want to write an academic paper in front of reviewers, or why wouldn't you review a paper that is being written in real time, or why would you not write a software in front of 4-year-old like kids? So there are a bunch of challenges that makes live creation and collaboration difficult. So I think the challenges in carrying out live creation is similar to that of performing a magic show or a music performance. First of all, the system should allow rapid creation because it should occur in very short time window, in the order of minutes and hours at most. And nobody would want to watch live creation that takes days and weeks. Also, it should look effortless to the spectator so that it is pleasing and engaging, but not exhausting to watch the process. Eventually, watching it should make them want to be involved in it. Also, audience communication is important because some of the actions are subtle and not transparent, and we want to intentionally augment the process and to make it easily understandable. And we want to make the artifact visible because that's what live means, and especially in the case of remote collaboration, making the artifact and the process visible can be an extra work. Furthermore, involving users in live setting and collaborating with them pose more challenges. It is because any non-expert user should be able to participate in the collaborative creation instantly. Because we cannot expect the participant will have any domain expertise, and we won't have time to prepare in advance. For example, participant will not have chance to go through interactive tutorial, or we cannot run a rehearsal. Therefore, system for live collaboration should carefully create a trajectory for anybody to immediately participate in the creation process. And we recently started to see some example in this domain. For instance, in this paper, a number of conference attendees were precisely guided by a set of smartwatches and computers through the process of building a large-scale architecture. To address these challenges, I have created a number of interactive systems and tools that support novel types of collaborative creation in live setting. And we have seen one of them already. And in this talk, I would like to present 3 more systems in each category. The application in which I can have impact is truly broad, and I have explored problems that can generalize across domains. Personally, coming from computer music background, A lot of my research work started in the domain of computer music, but those have implication in general creative domains, including writing, programming, crowdsourcing, and UI design. Largely, some of my early works are done in the context of live interactive music, but this talk will only cover live collaboration, but I'm happy to talk to you more about my creative practice if anybody is interested. So I would like to start with how we can support non-expert users to be part of live collaboration. Then I'm going to talk about how we can have interactive system that allows rapid and effortless creation for creators. And then I want to show what we can do when things cannot be done live, and how we can capture liveness in asynchronous domains. Lastly, I want to share the exciting research opportunity that I want to explore in the future. So let's first talk about how we can facilitate participation in live setting. So one of the most well-known examples of user involvement in live creation will be audience participation in a music concert. And it has been a long-standing endeavor for musicians to involve the audience as part of live performances, making them sing, clap, or stomp to the music. However, this is only limited to a very popular musician whose audience already know their music. So what can we do to scale this engaging user experience in general? So let's say I'm the musician and I want to involve the whole audience as the only musician of the music piece, for example, meaning that only sound of the music is coming from the audience seat, not from the stage. One of the opportunities that we have is to utilize the ubiquity of smartphone, because everyone has it already and it's powerful enough to run a mobile application that can emulate a musical instrument. However, that's not enough. Like, technical feasibility does not guarantee anything. Like, suppose I give all of you a violin and ask you to participate in the music that you never heard of. And probably either it's nobody going to participate or it's going to be very avant-garde piece. The challenge here is that how we can instantly turn non-expert audience member into a musician, and we have to give them a musical instrument that people can play immediately. The second challenge is somewhat opposite. If I give you a very simple, stupid instrument that you can master in 10 seconds, for example, and the question is whether you will be interested in participating in the piece for 10 minutes. That's going to be a challenge. We need a way to sustain their participation for the duration of the performance. The last challenge is that we are in fact going to perform a piece of music. Like, if people will play their own instrument without knowing anything, how can a musician orchestrate the crowd to perform a composed music piece? So CrowdNC is an interactive system that addresses these challenges of large-scale audience participation. This is the web-based musical instrument that I developed. Literally, anybody can play as long as they can open up a web browser on their smartphone, hopefully. So you can write a simple melody by placing these circles in the smartphone screen. And once you're done with your own melody, you can press this check mark button on the right, and now the instrument provides a way to navigate a network of melodies created by the audience members. You can browse what other people came up with, and other people will be able to see what yours too. So the instrument provides a temporary social media that people can interact with, and the simple melody that you wrote serve as a personal profile in the media. So you can see someone has more interesting pattern than the other that may inspire you to change your melody again. And the metaphor here was coming from Tinder, where you swipe left to browse more patterns, or swipe right to play together. If both parties like them each other, you will get this kind of notification with this delightful sound effect. So this is how the system manages audience members to instantly participate in the music performance and sustain their interest in social interaction. But what about music? Suppose there are 100 people simultaneously playing this instrument on their smartphone, and the collective outcome is not going to sound too interesting. In fact, because all the instruments are tuned in C major scale, it will sound like largely in C chord, but playing C chord for 10 minutes is not amazing. Like in Crowdesy, to perform a piece of music, there is a musician on stage who live codes the piece by sending code text from the laptop to all the connected mobile devices through the cloud service. So what the live coder does is to change the mapping of the instrument that people are playing so that the audience as a whole can make changes in music. For example, the onstage musician can change the current scale of the instrument from C major to E minor, for example. In that way, the musician can play simple chord progression and some melody over time, even with whole audience as a distributed musicians. The metaphor here is like the musician on stage is grabbing the chord of the fretboard of the guitar, and then the audience member is strumming the strings of the guitar. The cool thing is that the network structure between the musician and the audience allows the musician to grab the chord of 100 people's guitar. Another interesting thing about this remote programming structure is that the musician writes code, and the code will be evaluated on hundreds of mobile phones at the same time. And it resembles the highly parallel structure of GPU rendering computer graphics, where each audience member is a vertex or a fragment. And the code text is like a vertex shader or fragment shader. With this, we can split the crowd in multiple groups by incorporating randomness in the code text. For example, if I send code that says if random number generated is greater than 0.5, and then the code inside the if block will be evaluated with 50% chance, which means that the roughly half of the audience can play one thing, and the other will play the other thing. So with this remote and parallel coding technique, the musician can have more complex musical gestures. So I myself have performed this piece 4 times in public concert, which in total involved more than 250 audience members. Not only the piece was well received by the audience, but also the network traffic analysis indicated that the audience were actively engaged throughout the performance. As a follow-up study, we currently submitted a proposal to evaluate how the social aspect of the system facilitated musical creativity by analyzing interaction traces of each individual member. So to sum up, questions?
Just a quick clarification question. So are they playing for everyone else or just themselves?
Just.
So is everyone listening to their individual phone, or is
they're listening? Well, because because of the proximity of your smart speakerphone, you can listen to your own thing, but also you will be able to listen to the aggregated outcome from this piece. Yeah. So to sum up. To enable large-scale audience participation, I provided a musical instrument that contains social interaction in it, and I applied the distributed remote programming to orchestrate the crowd to play a music piece. So let's try to generalize this approach beyond music. Like for music, you can do a round of rehearsal and prepare in advance. So what can we do when it comes to non-musical domains? So I'm going to talk about how we can make the creation process rapid and effortless, making this live collaborative creation effective for broader domains. In particular, the domain that I have explored is crowdsourcing. Crowdsourcing has been used in a wide range of tasks that computer alone cannot automate or solve. For example, tasks such as labeling unknown objects in the picture or recognizing for poor handwriting. So one of the well-established approaches in crowdsourcing is microtasking. It is to split a task into a set of microtasks that an individual crowd worker can complete without context. In this approach, first, a requester needs to decompose the task into microtasks. And they're going to post them into crowdsourcing platforms such as mTurk, and workers will claim and solve the task. And when everything is done, the requester collect all the responses and use data to solve their own problem. For microtasking, requester needs to put lots of efforts in the task decomposition step as well as response aggregation steps. This procedure happens asynchronously, and it works very well for the tasks that can be done in massively parallel fashion. However, for some tasks, especially when they want to create something with crowd workers, microtasking does not work well. It is because the requester needs to know all the steps that are necessary to create an artifact in advance. So, for example, let's imagine how difficult it will be to create a set of microtasks of drawing this small portion of a larger painting. Coming up with a set of instructions per each individual microtask is going to be almost impossible. Rather, what really happens should be more of a continuous exploration of various ideas, iterating on the artifact with different fidelity. Therefore, I have worked on an interactive system in which a requester and crowd worker create an artifact in real time together. In this case, a requester will be involved in the crowdsourcing process, directly communicating with them and seeing what they're creating and giving immediate feedback on their intermediate outcome. The benefit here is that a requester can naturally and continuously interact with them, with workers, and the requester does not have to prepare too much in advance. However, the prerequisite here is that the system should support rapid and effortless creation for online workers, so that requester can instantly understand what's going on and artifact can be created in short time. So a particular artifact that we choose to explore is interactive prototype of a graphical user interface. Because creating sketch prototype is essential in user interface design, and because you can quickly explore different ideas and use it to communicate with other designers and developers. However, it is not clear from a sketch to know what is going to happen and when a user interacts with it, because it is a static drawing that does not respond to a user interaction. Indeed, a previous study reported that designers expressed difficulties in prototyping UI behaviors. Typically, what designers do is to describe the behaviors in text and annotate on the sketch. However, if you think of the actual behavior on the final product, like you see on the bottom, it would have been difficult to get the same feeling from the textual description. For example, when Steve Jobs demonstrated slide to unlock 10 years ago, people were applauding and screaming. However, you would have not got the same excitement if it reads slide to unlock on a piece of paper. As an option, we can hire an expert programmer and ask to write a program that can demonstrate an interactive behavior. But it can take days and weeks to actually see the result, which makes it slower to explore and iterate on ideas, especially at the early stage of UI design. To address this problem, I developed a Sketch Express, a web-based sketching system that helps crowdworker create complex interactive behaviors in a few minutes. It takes the idea of manually demonstrating interactive behaviors and later polishing the behavior by remixing animation. So in the system, a requester or designer verbally describe the interactive behavior that they want, and the crowd worker in the system that are connected to the system listen to the verbal description and create the behavior in real time. We provide an easy and expressive method called demonstrate and remix to make the static sketch dynamic. At the end of the day, the designer will have a sketch that includes multiple interactive behavior that can be triggered individually or simultaneously by anybody. As a requester's interaction with the system is natural, non-expert user can immediately use the system as if they are verbally asking to create an artifact to an expert. In Sketch Express, one can create an interactive behavior simply by demonstrating the behavior manually. So this is the interface that crowd workers use, and a requester will see the same canvas synchronized in real time like Google Docs. The requester will speak to the system and verbally describe a desired behavior. Let's say the requester wants a crowd worker to create a behavior of Super Mario moving forward or jumping forward. And then a crowd worker will listen to the verbal description, start recording, and demonstrate what is supposed to happen in the canvas for that particular behavior. Once created, one can replay the animation, and any change made in the canvas can be reproduced in real time as it was demonstrated. Let's say, suppose a requester asks the crowd worker to come up with a different jump behavior, and then crowd worker can be created to satisfy a subtle request. And this worker particularly decided to have a 360 flip in the middle of the jump. So when a worker animates an element to demonstrate a behavior, the system pick up the behavior instead of recording what's exactly demonstrated. For example, oops, I don't know why the video is not playing. But I mean, to explain what's going to happen is that it's going to repeat the behavior based on the current state. So if I press the jump animation, and Super Mario is going to keep jumping from where it stands. So this is because recording algorithm computes the difference between each event during the recording phase, and it will replay based on the calculated difference, or what we call delta. So recording and replaying by delta will expand the expressivity of animation in the system. For example, if I record an hour end of a clock moving from 1 o'clock to 3 o'clock, the system interprets the demonstration as an hour end rotating 60 degrees or 2 hours of elapsed time, instead of replicating the demonstration exactly. Another benefit of replaying by delta happens when a user triggers multiple behaviors simultaneously. This allows complex interactive behavior that needs concurrent action. For example, if I want to express Rolling Stone, there's no way for a choreographer to manually demonstrate this behavior because rotation and translation occurs in two exclusive modes. However, separately recorded animation of a rotation and translation can be replayed together to express a Rolling Stone animation. Most importantly, Sketch Express allows choreographer to remix demonstrated behavior afterwards. Suppose the choreographer is asked to create a behavior of mushroom dyeing, like in the top right picture. First, the worker will simply record the behavior based on what is supposed to happen. However, the demonstrated behavior is far from the given example. It is because the recorded behavior happens in real time as it was demonstrated. And for this particular behavior, it takes too much time to rotate the mushroom, and it does not immediately transit to the next motion. In this case, a choreographer can use remix function to adjust the timing of the behavior. With the remix function, a choreographer can choose to change the duration of each operation individually, or to replay an operation instantly, or even skip the operation if not necessary. For example, in this case, the rotation operation should happen instantly, and we don't want any delay between operation as well. We don't need any delay between two operations, and the worker can adjust the time of move operation as well to make it more dynamic. Now, as you can see, as the behavior is getting remixed, as the worker accomplished the seamless behavior, which is close to the example on the top right. Lastly, the created behaviors is stored as a reusable object so that you can apply it for other visual element in the sketch. For example, suppose the turtle moves in the same way that the mushroom moves, or die in the same way as mushroom dies. A choreographer can simply create a duplicate of interactive behaviors and apply it to another element. So this is an example of how far we can go with Sketch Express. This is done by a non-expert worker demonstrating the game Flappy Bird. As you can see, the game character, the background, the game itself is animated independently. Imagine how long it will take to demonstrate this by programming, for example. And you may be focusing on the left side, but there are more interesting things that are happening on the right side. Because by triggering right animation at right time, one person can accomplish to demonstrate a fairly complex game effectively. Another thing to note that is this is non-linear. So based on the sequence of behaviors that are triggered, you can demonstrate a completely different scenario. For example, you can demonstrate the scenario where Flappy Bird will die because it reaches the ceiling or fall down out of the screen. Through the in-lab study conducted with real choreographers, we measured how accurate the resulting behaviors are to the verbal description given, and compared the result with manually demonstrated behavior in the system. We could confirm the effect of demonstrate and remix method, yielding the increase of 27.3% in recall, significantly improving the quality of the prototype. And being able to later remix the demonstration helped accomplish near perfection in precision, because workers can simply delete any unnecessary operation made during the recording. Still, workers were able to create an interactive behavior within less than 3 minutes. So in summary, the contribution of this work will be an approach that allows rapid and effortless creation in the context of UI design, which can be used in a different domains such as making interactive illustration or robot programming by demonstration. Another contribution of this work is a crowdsourcing system that allows a requester to be involved in the creation process in real time with choreographers. And we also conducted a follow-up study to investigate the challenges that requesters have when collaborating and communicating with coworkers. So we have seen 3 different examples of live collaborative creation. In this part, I want to briefly talk about how we can have the benefit of liveness in asynchronous collaboration. Because a lot of the work that we do are not live. Rather, we collaborate in asynchronous fashion. It is because as much as we have benefit in real-time collaboration, we have benefit in asynchronous collaboration. For example, if 2 people work separately, they can work in the parallel in the time that they are available in private environments, yielding better productivity, hopefully. As opposed to for real-time collaboration, you need to find the time and space that everyone can work together in real time. And so it may not be best suited for the efficiency. The question that I want you to answer is how we can capture and benefit from liveness when we collaborate asynchronously. The particular scenario that we explored was motivated from the challenges that we have in seeking for help in a question and answer website, such as Stack Overflow. Asking a question in Stack Overflow is time consuming compared to asking a question to a colleague right next to you. You have to write down the question in text, and you have to copy and paste the code to give some context, and referencing certain part of the code in the question can be challenging due to the linear presentation of the code and the question. So it would be ideal if you have a person right next to you who has the right expertise to answer the question, but such support are not available when you need it, typically, and it can be inefficient than working in parallel, and does not scale well. To answer this question, I built and co-authors built Codon, an interactive system for seeking programming assistance from online. Codon is designed to support asynchronous question asking, the sequence of which is same as Stack Overflow. Like you first ask a question, and online helper composes a response, and then the developer will see the response coming from the helper and modify the code. However, in Codon, asking question is as natural as speaking to your colleague right next to you. It is built as a plug-in program of widely used code editor called Atom.io. So if you have a question, you can simply press the button and speak to the system.
So I'm trying to detect if there's any letter S in this for testing.
As if your helper is watching your monitor. In addition to the verbal description, the natural expressivity a programmer has in code editor, such as highlighting code, adding a comment, and scrolling will be captured so that the responder can see what's happening. And this simply took 20 seconds. Imagine how long it will take if it was a Stack Overflow. So this is Helper's website, and where you can play the question and the audio and replay all the cursor activity in real time. The benefit for helpers are that they can work in private without real-time pressure, but they have access to the code context in which the question asker was in when they asked the question. And one of the nice things in Codon is that the response came back from the helper is something that is worked on the code context already, so the response is presented within the editor that you are in. Furthermore, a developer can easily compare the response with the current code and integrate the answer automatically with the button click. Through the user study, we found that the participant who used Codon completed more number of programming tasks per hour than the participant who received assistance from a helper in real-time conference call, like Skype and synchronized editor. Key factors that contributed to the productivity gain was that the liveness preserved from the code context and the benefits of asynchronous collaboration where they can work in parallel and have less interruption. So we have looked at the system that I have developed to support live collaboration and capture liveness in various applications. So where we can go from here. And I want to share how my research on live collaborative creation unlocks an exciting opportunity for the future. In this talk, the question that I set out to answer was how liveness can improve user engagement in the creation process. And eventually this is about bridging the gap between two groups, creators and users. And just to remind you one more time, liveness in computational system means having immediate and continuous visibility to users. And I believe one of the main reasons why having liveness was effective is that it helps preserve the natural expressivity that we have, like verbally describing what we want, or wanting to socially interact with each other, demonstrating the behavior manually, or highlighting the code when you ask a question. So all of these activities are something that we have naturally, but often lost when we build a computational system. In conclusion, the technical contributions of my research is computational tools that support liveness and preserve our natural expressivity. So in the short term, my goal is to extend the notion of liveness to broader application and keep creating more expressive and powerful tools for collaborative creation. And I want to give you one example. So one ongoing project is about how we can preserve natural expressivity in augmented reality environment for co-located collaboration. As you can see in the picture, like current interaction in AR is very challenging in its input, in particular. For example, this is how we enter text in HoloLens, and this is simply exhausting to type. However, we already have a rich expressivity in traditional methods such as note-taking, sketching, or verbal description. So one of the ideas is to develop tools that can take input from the traditional method, such as handwriting or speech, and produce virtual elements in augmented reality environment. But I want to go further than this. If I have a method that can help bridge the gap between people, can you use the same approach to not just for user involvement and collaboration, but for more general context? Thinking even more broadly, and I believe a lot of the issue that we have discussed is about the process of understanding people and empathizing with people. So empathy means the ability to understand and share the feeling of another. In fact, many of the problems that we have can be explained as the challenges that people have in empathizing with others. Like designers not being able to empathize with users, or experts not being able to understand novices, or instructors not being able to understand the challenges that certain group of students have in STEM education. In this setting, it became clear that many of the challenges faced in communication are beyond the scope of solving with better collaborative tools. And we can start to think about how computational method can help better facilitate empathy and understanding. Therefore, the immediate future research that I would like to work on is to create and develop interactive systems that facilitate empathy. Psychologists and anthropologists view that empathy is realized through dyadic interaction. First, there's going to be empathizee, the people who want to be understood and express their feeling. Second, there's going to be an empathizer. There are people who want to empathize with other people. So there's a duality of this problem, and each group needs a different kinds of support. For the empathizee, the one who wants to be understood, we need computational tools for effective self-expression. And this is relevant to the work that I've been doing on preserving our natural expressivity. So one interesting question that intrigues me is how we can create a tool for self-expression and leverage people's desire of using such tools to teach them computational thinking or programming. Here are some high-level ideas that I have. One is having programmable interactivity in social media, because our ways to interact with other people in social media is limited. It's basically writing or posting picture or video. However, what if a user can write a post that has some interactivity? A simple stupid example can be a voting in Twitter or Facebook, but what if you can have more nuanced and personalized interaction by writing a program on a Facebook, for example? In fact, we already started to write code to use social media using services like IFTTT, or if this then that, or writing simple commands in Slack to remind my colleagues. And I believe social media can be a great end-user programming platform that people may want to learn code to express themselves to their network and to have deeper engagement with others. Another idea is, what if we can teach data science with the data that people care about the most? There are a tremendous amount of data for individual in social media, email, or calendar. And if people can learn data science with their own personal data, it will be a great tool for self-reflection and opens up an opportunity to learn more about themselves, their friends, and family. All in all, they'll be able to learn the efficacy of data science. So on the other side, there's empathizer, the person who wants to understand emotional feeling of the other. And then steps to realize empathy will occur 3 different steps. Cognition, perception first, cognition, and response. So the very first step needed to empathize with other people is understanding the perspective of the other and sharing perspectives, sharing what they perceive. To that end, I plan to build computational tools for sharing perspective. And I believe what I've done with liveness is one of the key elements in sharing perspectives. And I want to give you a rough example and show you one of my projects. So we often say you have to put yourself in someone else's shoes to empathize with other people. And what it means really is you have to learn someone else's perspective. Remember the food that I showed you earlier in the talk. And then maybe we value the food because we have seen the chef's perspective on the food by watching the whole process. And we can see that having liveness helped users understand something that they could have not otherwise. And I wanted to give you one more example. This is one of my favorite YouTube videos where a dog owner mounted GoPro camera on top of their dog and showed the video footage while the dog is left alone at home. As you can see, the room from dog's perspective is different from what you see, but more important thing is that we have a continuous visibility on the dog's perspective over time in the video. So I want to play the video a little bit. And I want to share some of the comments people left on the bottom of the video. And I find largely there are 3 types of responses. The first type of response is some people simply fail to engage with the video. They either just troll or want to make fun of the video. The second type of response is some people felt sympathetic for the dog. And they say it's sad, it's heartbreaking. And this is the most common response. However, there are a few number of people who were able to empathize with the dog. They said this video is scary and reminded them of watching horror movies. And I can see why they felt that way. Like complete silence, confusion, no sign of return, fear. That's probably what the dog would have felt instead of being heartbreaking for themselves. Clearly, this is a good example of how technology can help people literally gain new perspective. And the continuous visibility that this video provides helps some people empathize with the dog. So if we can have this computational tool that provides this kind of perspective of others, such system will facilitate empathy for users. So I want to show one example from my own work, which is called live writing. So to give you the live demo, it will be awkward not to have any live demo in my talk. So this is someone writing probably some sort of diary or an essay, I don't know, like maybe 6 months ago. But you are watching in real time. Like every keystroke that are made in the editor is recorded, and you can replay it in real. I'm playing in the 2.5. Like the playback speed is faster, but you can replay it in real time, and you can see how the writers write this article. Because writing is a real-time activity, but readers get to see only one version of it, only the final copy. So what if we can see the whole process, the real-time process of writing, and maybe you'll be able to learn more about the writer's thought process that changes dynamically over time. And you can start to think about how we can analyze this data, because all the keystrokes that are made is some sort of signal, like real-time signal. So you can see the number of added letters, number of deleted letters over time. So maybe you can see the peak on the timeline. You can see how this person maybe copy and pasted something from the web browser, or maybe if it was programming, because a programmer doesn't write code in linear fashion. They open up a bracket first, and then like go to the top and declare global variable and come back. So like such temporal structure can give you more information than just static copy. So this is an example there where we could use computational system to provide more perspective on people. So, oops, I lost my. Okay, so lastly, I want to say being able to help user empathize with others is not just about connecting people, and it's not just about having deeper engagement. I think there are so much more than that. Empathizing with other people is a way for us to see what's going on in people's mind and see what's going on in the world, which is what we call insight, a deep understanding of a person or thing. The promising thing is that we get to help people know how to gain insight, which is empathizing with other people. And the collection of insight is going to be an important vehicle for us to nurture creativity and innovation. With that in mind, thank you very much for listening. I wanted to thank all my collaborators, and I'll be very happy to take any questions. Thank you. Don't feel like this is very typical responses of my talk.
From a behavioral standpoint, I mean, I wouldn't say all of this, but a good portion of people in general has a strong sense of authorship, and how do you deal with that when you're dealing with sort of like this collaborative?
Authorship in the live running example that you saw.
Yeah.
So,
Like for design, for instance.
can you give me an example where?
You have that example of the graphic user interface.
Oh, you mean in the processing? So basically, they are paid workers. So anything that workers create will hopefully belong to the person who pays them. The other, actually, we had a similar question last time. The other aspect is that what if they bring some like copyrighted material from online and then put it on the canvas? And like because this is like early stage UI design, hopefully like such material will be filtered when we actually commercially launch the product or something. So there should be some sort of gateway that will like address that concern. But I know that could be a concern.
So you had mentioned that there are certain scenarios where you wouldn't want to have liveness or live collaboration, like if you're building software, Microsoft is building software or something. So like what kinds of scenarios do you feel like lend themselves really well to liveness? Or like what domains out there, kinds of, I guess music is one example, but like other domains that you think lend themselves really well to liveness and would do well?
Well, I think like being able to express yourself is one of the strong motivation to use such media. Like I would say personally, I couldn't think of myself like vlogging, for example, in front of camera, like improvising, like in front of camera, talking random stuff. But there are a lot of people who does that because this is a strong media that you can improvise and then interact with other people. So, and then even live writing, because you'll be able to present your writing in real-time domain, you may want to utilize the expressivity that you have, which you didn't have in static writing. So maybe writing something in slow pace or fast pace, or something that was written and deleted could be a method of expression. So if you have a desire to express yourself, that's the application where people will likely to use it. And then as people will be more open to the culture of liveness, like a lot of people these days just open up an Instagram and then like do live streaming and in the bed. I think this culture is going to be more number of people will probably hopefully use it.
So I guess following on that question, I'm curious about two things. So one, do you see liveness and collaborative creation as being kind of separable ideas? or how separable do you see them as being? Because I can imagine plenty of live systems
Yeah.
that don't actually involve
Yeah,
other people.
yeah.
And then too, I'm curious as, well, what you see as some of maybe the drawbacks of liveness is, I guess that's another way of framing
Yeah.
this question. So, obviously you chose to prepare slides and maybe do some parts of your talk as live. And in one of your systems, you had this idea of everyone having their own space before they kind of project something into the larger shared world where they could prepare something.
Yeah. So I believe liveness is not limited in collaborative domains. As you know, liveness has been coined by software engineering people, where having immediate feedback from the programming outcome in the environment, that's what's called liveness typically. So even in that space, even in solitary setup, imagine, let's make an analogy of programming with cooking. So in the old days, where you had to make a punch card for computing and then give it to someone in the center, it's like, imagine what it's like to cook in that way. It's like writing a recipe and then give it to a chef and then you get the artifact. That's probably that level of liveness for that punch card thing. But we cannot imagine a cooking process where you can see the artifact only every often time, only every 1 minute or something. That's what we do in compile and run programming. We write a code and compile it and see the artifact. You write a code and compile it and see the artifact. But in cooking, you can always see the artifact live. Like when you are chopping the ingredients, you can see it every time. So always. So again, liveness now is limited into in collaborative domain. You can have liveness in any kind of software that we use. The second question is about. So I guess the biggest threat will be privacy, where I mean the fact that everything will be recorded, and then if I write an article that people will see the whole things in the middle, I mean that will change my mindset, because I want to perform in some way, because I want to do well. Maybe I want to rehearse in advance to perform better in one take. So in that way, I am not claiming that everything should have a liveness. Every computer system should preserve liveness. But as I say, as the culture of doing something live is on the increase, they'll be able to. I mean, people will hopefully want to use more of these liveness features. As if maybe in the beginning of Google Docs, when I first used the Google Doc, I felt very uncomfortable that people are watching what I'm writing at the same time. But now I'm pretty comfortable with it, because I probably know this person is not going to watch what I'm doing, and maybe I don't really care. So I mean, it's some way it's a matter of culture as well. But I think it should be an optional, so that they can use liveness when they want to use it, but not necessarily all the time.
So a question is there a significant difference between liveness and real-time stuff? Because previously you mean liveness was immediately and continuously visible.
Yeah.
For real-time, I think it can be immediately be seen by people, and also if you scroll back on that, because it's slowly in database.
Yeah.
You still can visit it later on and continuously.
Right.
visit that.
Right.
So, what's the significant difference between the liveness?
So real time, that's a very good question. So real time means that you have a minimal delay between user or computational system, or user between two users, for example. So we say, for example, Skype is a real-time communication, but it's not live communication or live collaboration, because there's no artifact that they want to convey or deliver. So the fact that you have some sort of thing that you want to convey to the other person will change. Okay, I want to make this thing visible. And so the object is different there. But also, in terms of synchronicity and asynchronicity, let's say I told you liveness is the extent of which the process of creating an artifact is immediately and continuously visible. And that's, for example, the recording of live concert is not immediate because maybe it was from a year ago, but it still has some liveness because it has the continuous visibility. And at that time, it was live thing, right? So at that time, it has all the risk and uncertainty of what you don't know what's going to happen, and you kind of also see the continuous visibility there. So it will, I would say it will have less liveness because it's not immediate, but it still has the liveness component in it. So I'm not sure if that answers your question. Yeah. Anybody else have any question? Okay, thank you very much.